All right, we are live. It is 2:01 UTC, and welcome again to Astronomy Daily Live. Hope everybody's doing well out there in the universe and the world. Everything's good here. Got a little bit more rain, sort of unusual. Everybody's doing well out there in the universe and the world. Didn't stop this. Good here. Got a little bit more rain, sort of unusual. There we go. Sometimes I remember to do that, and sometimes I don't. So, all right. Well, cool. Well, come on in, friends. Come on in, and let's think and talk astronomical thoughts and topics for a while here, while we wait a little while to gather in more friends. I'll pop open the chat just to make sure things are being held down there. Okay. So yeah, everything's good here. So grab your consumable of choice. I've got some coffee here, so cheers. And I've got the good old standby HOH. This is hydrogen hydroxide. This is I don't know if there's any other molecule that is both an acid and a base. But HOH, right, the thing that defines an acid is if there's an H right at the beginning. And the thing that defines a base is if there's an OH at the end. So HOH is both simultaneously, right, an acid and a base. It's how does that work? I don't know, but it's pretty awesome. So cheers. And in the chat once again, or on the panel once again, is Bobby. Hey Bobby, what's up?
Nothing much. I like to say hello to Arthur Water. Have a quart of pina colada.
You have a quart of pina colada? Wow. That's that will have some effect, I would definitely say.
And I got me just regular faucet water.
Scott. All right. Well, that's almost as good. It's almost as good as hydrogen hydroxide. Almost. I can say though that this most definitely is not like pure, right? This has got all kinds of contaminants in it. Who knows what? But I like it all. As long as there isn't too much, arsenic and cadmium and sort of the heavy metals, and as long as there isn't any other particulates or anything that would cause some kind of problems. This is absolutely great. So, hey, you know what? I'm being summoned. I'm being summoned by one of the overlords to handle my doorman duties. I've learned over the years that if I don't respond pretty much like immediately, very, very, very terrible things happen. So I am going to exit just for like 10 seconds. I will be right back. All right, cool.
And I just want to let you know, Otto just got her Texan PO 880.
Yay! Yay!
And
Well,
yeah, going outside might be a better bet until like you have a way to like string yourself a wire, and then you might be able to do some outdoor listening right on the spot.
yeah, and if you live in a steel frame building, you got to get out. You definitely got to get out because yeah, that's not only going to block your signal, it's also going to scatter it and yeah, it's going to wreak havoc. So yeah, and make sure to get out. Um, yeah, sort of like a bomb shelter there, Patrick. So hey, nice to see you in the chat.
Haven't seen you for a little while, Patrick.
So yeah, ought to make sure to get on to Gilles' live streams and you know, point that out and yeah, you know, maybe he'll talk about it a little bit or you know, whatever, right? So cool, absolutely. So cheers. So I don't remember if it was. Don't know who asked yesterday if I had seen the weekly space hangout.
I think that was Tom.
I think that was Tom. Okay. Speaking of Tom,
And he's Tony.
pretty amazing though, huh? As soon as we mention Tom, he just appears in the panel.
It is magic.
You know, I'm telling you, there is something about this live stream that people are not catching on to, and they are missing some absolutely amazing things. I mean, I swear this. I mean, simultaneously when I said your name, you popped onto the panel. So that's very cool. Well, welcome, Tom.
Well, thanks. Sorry I'm late, but it's good to be here.
You know, as you know, this is a very, very casual get together, and being late just really isn't. That's not really a concept here. Yeah, so you come on in anytime you want, whenever. Always welcome.
All right.
So what I was saying is that I did actually get a chance to see the weekly Space Hangout show. You know, the most recent one with the JWST person, and yeah, that I don't know if it's just me, but that was kind of a weird interview. It I don't know. I mean, maybe there were other things on my mind. I'm not sure, but it seemed to me that just not a lot was actually said. It was really, really short, and it was just sort of like, you know, yeah, we're running late, but we think we're on time now, and that's about it. So
when we think about people going late, we usually think about Mormon Standard Time. We call that Mormon Standard Time here.
That's funny. And Patrick is still kicking. All right, cool. Very cool. Anyway, so yeah, that was kind of I don't know. Like I said, maybe
Patrick, I redid my room. Now I have space.
He has space for his coffin. So you know, when he's doing the vampire thing, he actually has room now. So cool. I didn't think that you wanted anybody to know that you were a vampire, Bobby.
I think Patrick just made that up.
You think? All right. Well, cool. So yeah, that that.
And I can't afford these lights for some reason.
What do you mean you can't afford them? You got them right there.
I mean, but these are not like those. This is like called track lights, and they usually are pretty darn high.
Oh, okay. Well, let's take a look. I think that looks adequate. I mean, if it's doing the job, works for me.
Yeah.
Yeah. So yeah, the other thing that I noticed with the weekly space hangout was they had a discussion of these various orbiting objects that they were saying, was going to cause all kinds of problems with the astronomical community. Having these big bright objects in the sky and all that, and they even referenced the Humanity Star object. That what's the name of that rocket? It's the Electron rocket, but what? You remember the name of the company that is launching those? Does anybody remember that? I'm trying to remember too.
Was that Proton?
Proton. They're launching from New Zealand. Is that it? I forget.
I'm thinking that's it. I'll see if I can find it.
Okay. But yeah, they lobbed the Humanity Star out there, and that lasted a few months. And,
Uncle Bill said Rocket Lab.
Rocket Lab, that's it. Yeah. Rocket Lab. Thank you, Uncle Bill. Yeah. So that was one of the things that was a little strange to me at the time. And Fraser mentioned it again that the Humanity Star was sort of advertised as this big, it's going to be this big bright object in the sky, and it was sort of made into like a disco ball shape. So because it was probably rotating, it would sort of twinkle, sorts, right? I mean, it would.
Uncle Bill, you just made me think that you may have like an IQ over 9,000. I'm just the one with the gun.
Well, yeah. I mean, in this age, knowing a lot of things is actually getting easier and easier and easier. But I've always distinguished between being smart and knowing a lot. Right? You can be smart and not know a lot of things, and you can know a lot of things and not be very smart. The thing that one should try for, right, is to be smart and know a lot at the same time. But that is really, really, really hard. So, yeah, and I'm sort of with Patrick on that. I am not going to claim to really know very much. I've heard a lot of things, but wow, to actually know something, that's a tough one. That's a tough one. So, all right. Well, cheers. Okay. One more thing about the Humanity Star. So that was sort of touted, right, as it was supposed to be this big bright object that was going to, ruin all the astronomical images and all of that. And well, I got to say that I think for the most part, the brightest that the humanity star got was about magnitude 4.5 or 5, and that was sort of late in the game when it was getting sort of closer in, um, just sort of barely visible. It usually sat around eighth or ninth or 10th magnitude. Because it's very small, and as reflective as those facets are, it's just it's so small and so far away. Maybe I'm like 200 miles or so. I mean, how well can you see um, some object that is a meter and a half across from 200 miles away? You can't see it all.
Uncle Bill Duran, special fondness for Rocket Lab just because electric turbopumps are interesting.
Yeah. I think what Rocket Lab is doing is some pretty amazing stuff, and yeah, I actually if you go to the everyday uh, um, astronaut, the everyday astronaut. I think his name is Tim Dodd. Tim. Um, he was actually just recently down there and sort of gave a little bit of a tour of the facility. I guess they built themselves a new control center, and he was able to sort of tour the production facilities there, and yeah, I mean, it looks very cool. And I guess they have a launch site currently in New Zealand, but I guess they're going to start launching from Wallops as well over in Virginia, right on the coast there. So yeah, very cool, very cool. Anyway, so
Vector sits high in my memory because they are the only ones so far to have launched from Spaceport Camden in Georgia.
Never heard of that one.
Me neither.
Cool. Yeah, I mean, it's sort of an interesting time for space flight because we're finally seeing sort of the privatization of this effort. It isn't just a sort of government thing anymore, right? We've got several private companies now in the United States and elsewhere.
How many of these companies are we looking at now?
I don't know. I mean, of ones that like have launched something into orbit. There's only a few, right? Maybe 3 or 4 or 5, but companies that want to do small payloads, suborbital flights, all of that, I would say that there's at least 10 or 20, if not more. I'm not exactly sure. Ivan,
now, what type of launches you want to see more?
what kind of launches do I want to see more?
Yeah.
I want to see launches of Hubble Space Telescopes. I want 1,000 of them out there, so we can just ditch ground-based astronomy altogether. Just forget about it, right? It's the Stone Age, right? And we just have a bunch of Hubble Space Telescopes up there, with all the time that we could possibly need, right? That's with 1,000 of them, that is 24,000 hours per day. So I think that's probably an adequate number.
Yeah.
I'd be happy with 100.
Interesting. I like to see like more launches of like. Have you ever heard of free to air broadcasting?
Free the air.
Yeah, like you get like a special receiver with a satellite.
Oh, nope, haven't heard about that one.
I heard about free to air when I was in Bowtech, and they got about kind of like about a few stations and stuff. I also heard it might have like radio and stuff that there are FTA too.
Cool. Anyway, so just finishing up on the weekly space hangout. The other, so they mentioned the Humanity Star, and that astronomers were really upset about that. And I mean, I looked at that. It's like, well, it's one object, and it's really, really, really faint. It's like, what's the big deal? And then they started to talk about these other projects where they want to somebody, I forget who, was it the Chinese? I'm not exactly sure.
Now, why is it every time when a failure happens, they always get sad instead of being more like dang it, dang it, dang it, dang it, dang it? It's like,
well, yeah, I don't know if sad is the right way of describing that. I would say it is more like a dang it, because I mean we don't like those kinds of things to happen. Sometimes what you'll hear is a lot of concern, right? A little bit of worry, because they're worried about, like in the case of the Soyuz failure, a week ago or so.
So it's becoming more of a whiskey tango foxtrot, right?
Yeah, it sort of is. It's like, what is going on, right? Anyway, yeah.
Would have been worse if it was whiskey tango foxtrot hotel.
So they also talked about a couple of other projects, like I said, that I think one of them was like a Chinese thing where they wanted to, put up some kind of like a big mirror that was going to be, extremely bright and all of that. And they were sort of going on and on about how, well, about how that was going to, interfere with.
Welcome, Thunderbird.
Hey there, Totterbert. Interfere with these astronomical observations, and I'm not seeing that, right? I mean, it's one, regardless of how they sort of decide to do it and all of that, it's that's one object, and I think I mean, like I said the other day, I think the real concern is the satellites that are up there now, and this plan to essentially double the number of satellites up there now. That is I think a larger threat to ground-based astronomy than any single some kind of mirror or something. It was just that was kind of a strange episode. I'm not quite sure, but they seem to be off on that one. So anyway, just my feeble interpretations of things, I guess. So cheers.
They were doing that from different surroundings than what Fraser's used to. I don't know if that had much impact on the podcast, but a little bit different for him, I guess.
Yeah, yeah. I'm not sure. They with these satellites. I mean, you've got to think about that a little bit. What's going to have a greater impact on ground-based astronomy? A single object that you know is probably not going to be seen by you, or 12,000 of these things. When you're trying to collect data, when you're trying to make a photograph, all of that, you're going to have these lines through all your images. And it's like that sucks. So yeah, just not very well thought out, I don't think. So I've actually heard about um, those mirrors in space for, wow, 20 years at least. Um, it was a um, it was a way, which I think is actually pretty clever, um, of in terms of a military kind of thing. If you can turn the I don't know what the terminology is, but the place you're fighting, right? If you can have like constant daylight on that location, it doesn't get dark. I think in terms of militarily, I think that's that's an interesting advantage, maybe. I don't know. I don't know. So it's an interesting thought. Whether it's going to happen or not, I don't know. I don't know.
I
Um,
think your computer just went back to the media player.
oh, I know why it did that, because I forgot to put it on repeat. So here, let me restart it here. Hold on. Hard. It's much more difficult to do this with a kitty on the lap, but that's what I've got.
Maybe you should try getting a Logitech K400.
Actually, I think what I need is just a bigger lap. There we go. Okay. All right. Tails in the way.
And
Kitty's
you
on.
just messed up your microphone.
Just messed up the microphone. All right. Well, cool. So, let's see. Where should we go today? I was actually. You may have noticed that I started a little bit late, and that's because I was actually going through archive.org, and I didn't actually get all the way through it. I was seeing some interesting titles, and so I was being incredibly distracted by those, and actually started reading a few of the papers, and I look up at the clock and it's like, uh-oh, I better go. So uh, why don't we take a look at, I posted a few of them. um, let's see, where am I here? Papers. Okay. So yeah, there were quite a few kind of interesting ones today. So let me share my screen, and we will go to infinity, and then we'll go over to the Discord server. If you haven't joined up on the Discord server yet, I encourage you to do so. There should be a link down in the description of this live stream that contains an invite. So I think you click on that, and then, yeah, I'm not exactly sure what the process is, but eventually you'll get in, and you'll see several channels over here, and under papers, I try to list papers that I sort of found interesting. Feel free to post things here for sure. This is not just my playground. This is everybody's playground. So yeah, feel free to post papers here that you think are interesting, and given the opportunity, I will definitely bounce off of your ideas and take a look at these things. In fact, Tom posted a couple of things today, as I recall. The Skeptic Zone podcast. I don't think I've ever heard of the Skeptic Zone, so I will definitely have to check that out. What's this about, Tom?
Well, the Skeptic Zone podcast in general is basically some folks who are skeptical folks about, mainly they look at homeopathy and some of those other things and try to debunk, that those are really cures. And but the what I posted today was kind of a special edition. There's something called Skepticon in Australia, and Pamela Gay, Dr. Gay, was there for that convention, and they interviewed her on their podcast from last week.
Oh wow, very cool, very, very cool. Yeah, and I'm trying to think of the term now. There are skeptics, and then there are I forget the other word. This is the problem with live streaming, is that trying to think of things right off the top of your head, it's like phew, gone. Yeah. Well, it's it of course is extremely important to be skeptical. As long as you, well, at least as far as I'm concerned, as long as you're do a good examination of what you're trying to debunk or look at in some kind of really, really hard way, because you never know where a great idea or a great revelation is going to come from, and so if you hear some kind of crazy idea, right? Be skeptical of it, but take a good hard look, run it through the ringer, and see what happens. So, well, cool. I will definitely have to check that
And we
that
just
out.
lost Tom.
Lost Tom. He jumped off. All right. Well, maybe he'll come back. Hopefully. So yeah, there's another podcast. Hey, you're back. There's another podcast that I listen to on occasion. I think it's called The Skeptic's Guide to the Universe. I think that one's pretty good too. So yeah, definitely check those out. And I thought that Tom posted something else. This you did the other day, which I saw. Well, I saw the post. I didn't actually look at it. But I thought that you had posted something else, Tom. I don't remember what it was or where.
Let me see if I can look around here. I can't remember if I did one thing or two today.
Yeah, I thought there was something else. But okay, well, if you can find it, we'll take a look at it. But let's as I said, I didn't get through all of archive, why don't we do that really, really quick? So this is archive.org. Here's the main site. And this is just, the bleeding edge, newest papers that have recently, been accepted for publication in all kinds of topics, right? Not just astronomy, but lots of physics and math, computer science, biology, finance, stats, electrical engineering, economics. So all sort of the latest and greatest. And most of these go back now years and years and years. And of course, the one that I look at most is the astrophysics one, or the astronomy one. And they post new papers every single weekday around 1 hour UTC. So about 1 hour before this live stream starts, I'll go over to archive and start taking a look at the newest papers that are out. And like I said, I didn't actually get very far into these because there were some pretty interesting ones. This was one of them, the spiral structure of the Milky Way. That is a very, very hard problem, I guess you can say, because we really don't have a good idea about what the Milky Way galaxy looks like. It's sort of, what I always think of it is it's sort of like, trying to take the picture of the outside of your house from the inside. It's just it's not so easy. And so, from time to time there are these attempts to do that. And actually, this is a pretty cool paper. They go through a bunch of different ways of being able to do that. And yeah, I think this might be the one that we should take a look at. But sometimes I just like to go through archive.org with you all and yeah, see if there's anything else. This one I thought was interesting too. They actually correlated observations of two observatories out in space, Kepler and TESS, and it turns out that these two spacecraft actually simultaneously observed something like 171 stars. They just so happened, to be observing at the same time and looking, sort of in the same place. So that I thought was kind of neat. They don't actually do anything with the data. They just sort of, point this out. So I guess it's up to somebody else to actually see if there's anything interesting there. But yeah, to simultaneously observe objects or events from multiple points of view, that can be pretty valuable. So kind of neat. Let's see. And there was the last one here that we will see. Yeah. So this is the one that actually got stuck on. Now I'm a fully admitted sucker for these occultations. I like occultations. I think they're extremely cool, and depending on the means making these measurements, you can actually learn a lot about um, the objects, that are doing the occultation of these stars. And in this case, and I actually have to probably go through this paper a few times because it's pretty complicated. But they think that they observed the occultation of a star by a satellite of a trans-Neptunian object. So it's pretty amazing. So yeah, I was just getting into it a little bit, and then as I said, I looked at the time, and I was like, oh man, I got to go. So yeah, I really haven't had a chance, to look at this much, but I really like occultations. I think they're extremely cool, and like I said, I think we can learn a lot. We have discovered rings around some asteroids using the occultation method. We were able, to measure the thickness of Saturn's rings with occultations. It just goes on and on and on. And occultations are just really, really cool to see, because, I'm going to come back to me for just a second here. I've been an astronomer my entire life, right? So I've been looking through telescopes and observing galaxies and stars and all of that for decades, right? And when you look at the sky, it more or less always looks exactly the same, and nothing seems to really be happening all that much. But let me tell you, when you observe an occultation, and you're watching this star, right? And it's there, and then all of a sudden it's not, and 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 then all of a sudden it's there again. It's there. That's to see something, changing like that in the sky is it's just, at first it's sort of like, wow, that's mind blowing. But then one realizes that it's happening all the time. All the time, there are these transient events that are going on all the time, right? In fact, the LSST, the Large Synoptic Survey Telescope, which is being made right now. I think they're still making the mirrors. I don't think that they've broken any ground or anything yet. So it's still several years away from running. They're saying that they're going to be sending out something like 1 million alerts every single day, and maybe even more of these transient events, right? Which could be an occultation, it could be a supernova. Trying to think of other transient events. I don't think, it's not going to be able to see like gamma ray bursts or anything like that. But yeah, so these transient events actually happen much of the time. They only last for a short amount of time, and so actually being able to observe them, you sort of have to be at the right place at the right time. And with occultations, that's absolutely true. Absolutely true. So yeah, all right. Well, enough about that. I really like occultations, obviously. Let's see. Let's go back to archive. So yeah, I sort of got stuck on that. So I haven't. looked at anything else here at all. So let's see. Absorption profile, 21 centimeter measurements, H2 regions, wave asymptotics. Okay. Two squid amplifiers. This is some kind of instrumentation here. Instrumentation. The time evolution of the Milky Way's oxygen abundance gradient. I didn't even know that the Milky Way had one of those. Radio type 4 bursts. Interstellar ions. So what I usually do is I just look at the titles first and see if anything sort of grabs me. Pretty much any time that an actual object is mentioned, I'll sort of take an extra look at that, because I like to look at the individuals like that. A lot of these are theoretical or models or surveys. Spacecraft telecommunications. That looks a lot like the, that's the next generation VLA paper. I recognize that one. Planetary nebulae. Wow, I don't even know what that means. Huh. The acoustic tachocline anomaly. Let's see. This says green peas in X-rays. So now that's a catchy title. Let's let's see. Reionization of the universe after the Dark Ages played an important role in the galaxy formation and observability. The source of the ionizing radiation is, however, not yet clearly determined. The main contribution is commonly attributed to the strong active galactic nuclei activity or tremendous star formation. Blah, 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 blah. In this paper, we present the first measurements of green peas in the X-ray domain. That rings a bell. That's some kind of an X-ray thing, isn't it? Yeah, man. I'm trying to remember what that was. I thought that we'd come across this concept of green peas before on this live stream. I don't remember now exactly. We should go and at least find out again what green peas are, because I think that's an absolutely fantastic name. It's so let's take a look at the paper here really quick. See if we can just look in the introduction and see if they offer an explanation. I hope that they do. Okay, actually, green peas represent a class of compact, high star-forming galaxies that have recently been found to show signatures of the escape of this ionizing flux. Okay. I'd like to know a little more.
I don't think I've ever heard that term referring to astronomical.
I thought that we talked about this a while ago. I can't be sure though. So green peas were originally discovered in the Optical Sloan Digital Sky Survey. They're compact, low mass, a billion solar masses, merely a billion solar masses. But that is compact and low mass, right? let's see, highly star forming, 10 solar masses every year, with strong emission in the Lyman alpha line um, of hydrogen. Let's see, green peas are therefore convenient local laboratories for testing the conditions in actively star-forming galaxies and their role in the reionization era. Well, I'd sure like to know why they're called green peas. I have to investigate this a little bit more. Doesn't look like we're going to get an answer here anytime soon. All right, well, we'll look into that a little bit more. No worries. On Astronomy Daily Live, we follow our noses, and this is definitely not sort of the end of the road. It's just let's just make it a slight pause. We need to find out a little bit more about green peas. That's just way too good of a name to pass up. So let's see, slingshot prominences. So there was a CME on September 10th, 2017. Okay. We could probably find a picture of that. Dust levitation in an inverse sheath.
Check the chat.
Check the chat. Check the chat. Check the chat. Laser beams, yeah. Hey there, Hip.
What's up, Hip?
Oh yeah. Yeah, we're gonna have to investigate these green peas a little bit more here. Find out exactly what they're talking about for sure. Yeah, that is basically us, dust levitating. Let's see. Homogeneity as a standard ruler. Curious case of Swift J1753.5 minus 0127, a black hole, low mass, X-ray binary analog. Okay. Okay, that's it. Well, today there were merely 64 new titles, and yeah, let's go back and sort of look at this. At least start to look at this spiral structure of the Milky Way. That was pretty informative paper, actually. Coming out of China. Very cool. It's nice to see that. Very nice to see that. So let's see. Wow, so more than 100 models have been proposed to explain the spiral pattern. But let's see. Uncertainties, difficulties in determining an accurate rotation curve, kinematic distance, ambiguities, and deviations from non-circular rotation. Huh, okay. Well, we're not going to get into all of these, but this is sort of the section that I really like. So it's like what is out there in the sky that might be able to be used to trace the shape of supposedly these spiral arms that the Milky Way has. And so identified actually quite a few And I don't think any of this is really new information, right? I mean, I don't think that they've come up with any kind of new um, um, tracer, but they do have a bunch of new measurements and whatnot. So yeah, star forming regions, we are pretty sure are in the spiral arms of galaxies. I mean, we observe these when we look at other galaxies. So there's no reason to think that uh, um, the Milky Way wouldn't be like that. So yeah, we can look at the positions and distances of star forming regions and see how well they trace out any kind of a spiral structure. So that's pretty cool. I think they actually have a distribution of H2 regions. And I hadn't spent a lot of time looking at these, but I was trying to sort of understand their coordinate system here. It sort of looks like this is our location, right here, and then this is just a distance. And again, it's a little confusing because, see, this way it goes, this first large mark is 15 kiloparsecs, 15,000 parsecs. But over here, 15 doesn't show up until way over here. So I'm not quite sure if we're seeing this. I'm not quite sure. Not quite sure. This is obviously looking around in a circle, right? So this is looking north. Maybe we can get some indication here. Okay, so the two black stars indicate the location of the sun, right there, and the location of the center of the galaxy. Oh, I see. So, okay, that makes more sense, right? So 0, 5, 10, 15. There we go. Okay, so these numbers here are distances from the galactic center, not the distances from us. That's why I was a little bit confused. So, okay, let's see, position uncertainties. Yeah, that's what all those are. Galactic longitude in degrees. Okay, so this is galactic longitude. Okay, cool. Right, I gotcha.
Hey, Cosmic, what are kinematic distances?
Yeah, that's kind of a strange term, isn't it? Because kinematics has to do with sort of the properties and motions of things, and so a kinematic distance. Yeah, I'm not sure. In fact, I'm not quite sure what even a spectroscopic distance is. I'm not quite sure how. Yeah, we're gonna have to look into that a little bit. I mean, obviously, we've come up with a number of different ways of trying to measure or at least estimate distances to things. The best way is parallax, but the problem with parallax is that only works for objects that are relatively nearby. Within, I don't know, 500 light years, maybe 1,000 or so. And the galaxy, right, is something like what, 70, 80, maybe 100,000 light years away. So parallax, like on this scale, right, only works for just a tiny region around the sun. So we've come up with these other ways of measuring distances, which are guesses, right? We take our observations, we plug them into models, and we make some kind of a guess. So a spectroscopic distance and a kinematic distance is obviously one of those. There are other means of measuring distances, but what those exactly are, I'm going to have to try to find out, because I'm not exactly sure. But this is what they've got, and let's see. So on the left is the so-called spectrophotometric distances, and on the right are spectroscopic and kinematic distances. And I don't know if I'm seeing any kind of structure there or not. I mean, obviously there's some patterns, but it's hard to interpret.
I posted a definition I found online, but I don't really quite understand it still.
Okay. Did you put it
in chat? Yeah.
Okay, so kinematic distance is a distance to an object within the Milky Way based upon a map of general movements, orbits. Okay, all right. So I think I guess where I would go with that is if they can measure the proper motions of these objects, then there may be a way to sort of infer a little bit about their distances. Yeah, that's a toughie. That's sort of a stretch, for sure. But that's sort of my interpretation of that. Is that maybe they're looking at proper motions, because over the course of 10 years, 20 years, 50 years, we can see most things moving. Most things. So that's my only guess at this point. So cool. All right. So anyway, so that's one way, is to look at these star forming regions, because the idea there is that these things are sort of tracing out the spiral structure. They can also look at just hydrogen, right? They can look in the radio. 21 centimeters, I think, is I want to say it's like 14.3 gigahertz. Is that right? Does that sound right? I don't remember. And again, at least the theory goes is that spiral arms are locations are structures in the galaxy where there's sort of more stuff, right? So that means that there's going to be more hydrogen in the arms than there are, outside of the arms. And so we should be able to see a stronger signal there too. So that's another way. So we can look at just plain old H1. And let's see, do they have, I thought they had a map of this. Maybe they have one somewhere else, not exactly sure. But I'm seeing words like large uncertainties. So, yeah.
Yep, good night, Atta and Talibert.
Yep. Good night. See you next time. Let's see. So they can look at molecules. Those also are most likely going to gather in the spiral arms as opposed to anywhere else. So that's pretty cool. Another way. Let's see, where else? Okay, here's some more. Okay, so this is the distribution of molecular clouds in the galactic disk. So this is pretty much the same that we saw before. And yeah, okay, you know, we're sort of seeing structures here, maybe. This in here looks a little dense. I don't know if I'm going to try to zoom in here and see if it becomes a little less dense. Doesn't look like it's going to. Whoop. Yeah, so kind of hard to see anything here, but yeah, you know, maybe there's some structures here. You know, I mean, again, right? I mean, this is the center of the galaxy, so one would sort of think, at least, that, you know, the spirals are going to be centered on there, and I don't know. I'm not seeing much. I guess what I wanted to do was look at the caption and see if that's revealing anything that I'm not seeing. Let's see. The symbol size is proportional to the mass of the molecular clouds. And let's see. Position uncertainties. So you can see the little all these gray bars here. So that's, you know, those are the measurement errors of the positions of these things. So yeah, kind of all over the place. On the right, okay, so this is just sort of a different way of looking at it. They're looking at carbon monoxide. So that's pretty, well, come here. That's kind of interesting, right? We're actually seeing maybe a circular pattern here. Kind of hard to tell. This is hard stuff. So let's see. So looking at molecules, we can do that. They can look at open clusters, because supposedly, again, you know, the open clusters are typically going to reside in the spiral arms. Let's see. So the two black stars indicate the location of the sun and the galactic center again. So here's, where's the other? I see one star. Where's the other star? There's one star down here. See another star somewhere? I sort of thought that was where our sun is. It's my guess. I think so. So let's see. So distribution of young open clusters with an age of less than 12 million years. And here are the open clusters that are older than 20 million years. And I guess they've sort of taken some models of where the arms maybe should be and overlaid them here. And yeah, here we can definitely see that, yeah, maybe these clusters are sort of gathering along these lines, but yeah, I don't know. Without those lines as a guide, I don't know. And here it's, yeah, I don't know. I mean, this one sort of.
The two black stars indicate the location of the sun. As you can, if you read the description.
Yeah, I saw that of the sun and the galactic center. Okay, so I'm looking for black stars, and I see one black star here, and that's it, right? So this, I'm pretty sure, is the center of the galaxy, this one, right? But where's the other black star? I don't see another black star. I see a circle with a black dot in it. I'm not quite sure if that's the location of the sun or not. Sometimes these papers, people miss things, and that just might be, just a little typo of sorts there. But yeah, are we seeing any spiral structures here at all? I don't know.
Unless those lines are the spiral structures.
Well, yeah, those lines are models that are supposed to sort of, at least according to the model, that's where the spiral arm should be. So, but yeah, I'm not really seeing anything, right? So, but I guess that's another way to use open clusters. And then, yeah, they sort of get even more complicated here with these spiral arm tangents, tangencies they call them. I'm not quite sure what a tangency is. I'm going to have to look at that one too, because that's yeah, all these new terms. I don't know, but I think I was looking at their conclusions here. Okay, yeah, here's just some more things. So here are at least what the models are saying where the spiral arms should be, and this is where the observations place, these particular objects. I guess masers are the triangles, and O stars, which are very, very large hot stars. So again, it's sort of like, are we seeing these fall into any kind of a pattern or anything? I don't know. That's hard. That's hard. And these error bars here are really big, right? Really, really big. So the position of these might be here, but it could be here, and it could be way out here, right? It could be anywhere in there. We really don't know. So yeah, this is a tough nut. A tough nut for sure. M101. Let's see. So let's get down to the. But yeah, pretty interesting paper. Good read. Complicated. Pretty complicated. So yeah, they talk about limitations of facilities that they have now, and trying to see. I think they were. Where was I seeing that? Yeah, so astrometric errors are large due to the sensitivity of the instrumentation. Most of these objects are extremely faint and hard to see anyway. So yeah, trying to get a good position is really, really hard. So yeah, this is just an ongoing project, and it's a tough nut. It's a tough nut, because we don't have this overview, right? We're inside the galaxy, and so trying to figure out what it looks like from the outside is really, really hard. Well, we're doing it like this at the moment. Are there better ways? Yeah, maybe. I don't know. Anyway, so yeah, a lot of this work is really, really hard. Extremely interesting though, and this kind of work is neat because it sort of pushes the technology, right? It's like, look, we want to be able to map out the structure of our own galaxy, right? So what do we have to do in order to do that? Well, we have to make measurements that are really, really, really accurate. And in order to do that, you have to have the instrumentation. You have to have the software to deal with all this. If you rely on models, you have to make sure that the models are um, um, as good as you can make them. Yeah, it's just a tough nut. So, but I like to see that kind of work because it really is sort of bleeding edge. I mean, that, trying to figure out, the structure of our galaxy is definitely one of those really, really cool, sort of bleeding edge projects that we will have an answer to at some point. But at this point, there's a lot of uncertainty, right? We have a pretty good idea that we're probably in a spiral galaxy because we look out and we see, objects that characterize spiral galaxies that we see elsewhere, right? Star-forming regions, clusters, those kinds of things. But what it exactly looks like, don't know yet. I think we'll get there eventually, but it's yeah. I mean, like I keep saying, it's a tough nut for sure. All right. Well, I am way over time. Talking astronomy. I could just go on and on and on. So yeah, but I think I'm gonna cut it for today. So thanks for coming in, everybody. Have a great evening, a great day. Make sure to subscribe if you haven't already. You can hit that little bell thing to get notifications when I come on. But this live stream usually always starts at 2 hours UTC and goes for, well, it usually goes over an hour, but I try to keep it, close to an hour if I can. But, this is astronomy, so, to try to talk about universal things, yeah, it can go on and on and on. So, all right, well, take care, everybody. I will see you in a little less than 23 hours from now. So take care. See you later. Bye.
Bye.
Later.